Based on Hubert's oil peak theory, the mass usage of fossil fuels is shortening its lifespan. As a response, scientists gained interest in the numerous unused energy sources. As you can see, about 71% of the globe's area consists of water surfaces, of which every inch stores energy. Thus, we decided to focus on oceanic energy phenomena and specifically tides. Imagine the energy needed to elevate an ultra-large crude carrier of 550,000 tons of deadweight tonnage. Well, that's only a fraction of the energy laying fallow in this phenomenon. The question is, can we effectively exploit this energy? One of the most efficient modern energy processors are the hydroelectric generators, which produce electricity from water's potential energy at mechanical efficiencies greater than 90%. So can we assemble a device that benefits from both high predictable tidal power and high mechanical efficiency? We invented a device that can transform the energy of tidal motion into potential energy. The concept lies in the variation of the submerged height and the subsequent alteration of the upthrust force. This breaks the equilibrium between the weight and the upthrust. While approaching the low tide, the resulting force downward applies pressure on a water-filled compressor or piston, forcing water upwards into a high potential reservoir which can then be used to generate electricity. And while approaching the high tide, the net force upward pulls the piston, filling it with water. To avoid back suction of water from the reservoir and water loss during compression, non-return valves are installed as shown. After testing the device practically, modifying it, and calculating an efficiency, we then carried out the following experiment. The independent variable was the rate of depth variation, and the dependent variable was volume of water output per unit time, to test the device's response to the height variation in different rates as to simulate the actual variance of tides. We plotted the results of our experiment, and the graph showed the direct proportionality between the dependent and independent variables.